Okay, we are now live on this second meeting of the seminar on Intuitionism and Constructive Mathematics. And eventually some people will join in, mostly students who are not able to be here. So today we're talking about this article by Brouwer on the unreliability of logical principles. And before I start that, I would like to give a little biographical sketch of Brouwer. I said a little bit last week, but I think more is in order to understand particularly where the first section is coming from, which is not what we're going to concentrate a lot on. So there are three sections to this paper. One is about his logic in science, and there's a very short section on logic in wisdom, as he calls it, or I guess religious mysticism, something like that. And then the main section is about logic as used in mathematics. And for the second half of today, we'll talk about some meta-mathematical results about Heiting arithmetic, and we'll just try to sort that out and get that started. I'll also include that in my little bio and history outline, just so we have an idea of when this happened. We're kind of jumping a little bit in time, but I think it's good to have a discussion also of these developments in the formalization of intuitionistic logic. So we'll jump a little bit ahead for that today, and then next week we will talk about Brouwer's analysis, mainly what he got out of the bar theorem, the fan theorem, how he concluded that all functions on the unit interval to the reals are uniformly continuous, what his arguments were, what the structure of that was, and we'll come back to that later in the course as well. So that's next time. That's this. The 26th of January and the 2nd of February, we'll talk about Markoff and Russian recursive mathematics. And then I'm very happy to announce that on the 9th of February, Frank Fenning has kindly offered to give a guest lecture while I'm away about verifications in the style of Martin Löf and whatever else he wants to elaborate on that. So it'll be very exciting for all of you, I hope. I'm very grateful to Frank. Okay, so now, a quick story about Brouwer and some timeline of events. Try to see if I can fit that. Start around here. So Brouwer was born in 1881. I'm going to mispronounce this. Do we have any native Dutch speakers today? I think it's going to be a rare occasion where we don't have a native Dutch speaker in the room, so we can't be corrected, but it's this Overski, Overski maybe. So this is now a part of Rotterdam, and it's where they put the airport. So basically now it's just the Hague airport, I think. But okay, it's good to know. Now you can sort of calculate how old Brouwer was when various events occurred. So he was kind of a genius as a kid, as you might imagine, very promising, entered university at 15 or 16, studied math and science. And then he developed some peculiar ideas as he was older. So in 1905, he published a book called, in English, Life, Art, and Mysticism. Where this is his philosophical manifesto, if you like. So this here he's decided on his philosophy of life, and he writes it down, and this is his. He's very proud of this book. He tries many times to get it published in English, but it never happened. So it's only in, I guess, the 90s that Van Steekt has a full translation. His student Heiting, one of his greatest disciples and spokesperson for Intuitionism, was very embarrassed about this. He didn't want it included in Brouwer's collected works, which he was the editor of. Only like the small passages that were relevant to logic, he allowed those to be included, but not the main work. But now you can find it on Project Euclid, and it's a translation if you're interested. Let me just mention some of the things that are in there. So there's a religious, Christian religious, that
the path to salvation is through solitary thought, withdrawal from life. You have to, he writes something about that he know of only two beings that he can really know. It's kind of a maybe Cartesian idea plus one, because he knows about himself and God. And God is separate from him, but otherwise he has only his own mind and his own soul. And so he has to think about that. So he builds also in this year a cabin like out in the woods away from Amsterdam, where he can withdraw from life and be himself. So there's a clear, people call it a solipsism, kind of, I guess, not quite wrong, at least. What else is there? There's an environmentalism, back to nature. Science is evil. Communication between people is inherently flawed and difficult. You can never trust language. That's something, I guess, that's relevant for his mathematics as well. Okay, we have someone. Come on in. It's locked. Hello. And I think we should also mention that in this book and in his philosophy, there's some very, we would find them appalling passages about women, that they're of a lower order and they can never be trusted. But he was married, but he still wrote these things. And I guess it's kind of par for the course.
Do you know whether he cites any philosophers that he read that inspires this kind of?
I know he was inspired by Kant. There must have been others that he mentioned, but it's a good one. You can have a look and see.
I wonder if you had read Kierkegaard or something.
It could be. Yeah. I haven't read it myself. I only sort of got the notes version of it to relate to you. Yeah. So science is evil, and you only have your own mind to trust. That's how the gist of it. Okay. But that's about the same year he starts working on his dissertation. So that finished in 1907. And that lays bare his program for renewal of mathematics, and it also contains some very important steps towards the solution of Hilbert's. What didn't write on the fifth? I think that the problem about Lie groups, maybe it's the fifth problem. So he does some important work on that. It's called. For some reason here I wrote down the Dutch title, so it's over the Grundlagen. Der Visconde. So it was written under, I guess, the direction of Korteweg. So Korteweg you may know as a brilliant mathematician of differential equations. So he was not so happy about this turn Brouwer had to focus on foundational matters. I mean, he was very happy to just study Lie groups. That was fine, but I think there are many parts of the thesis were not included in the final manuscript because Korteweg said this is not something that's appropriate for mathematics dissertation. But the title is about the foundations of mathematics. Visconde is Dutch for mathematics. Okay, and then we have the today's topic. Unreliability. And this Brouwer got published in a Dutch philosophy journal. So I guess this was on his mind, and one of the main things, I guess, what he was trying to communicate is new conception of mathematics, that it has to be rebuilt on a new foundation. And he wanted to publicize that, at least in the Dutch community. But otherwise, those years from 1907 to, I guess, about 1913, that's his main topological period, where he proves many of the theorems that he is famous for among all mathematicians. So topology. So he basically revolutionizes combinatorial topology and algebraic topology. He defines degree of a mapping. He proves invariance of dimension. Let's see, what else did I have here? The fixed point theorem, of course, and the extension of the separation theorem to arbitrary dimension. And of course, in order to even prove something like invariance of dimension, he has to define dimension, which is also a breakthrough. So many things that he's rightly famous for happens in just this short period of time. Then he becomes a professor, first a professor extraordinarius in 1912, and then an ordinary professor in 1913. And then he says, okay, now I've proved that I'm a good mathematician. Now I can return to my foundational program. So that's when he returns to logic and foundations. Okay, so that, let's put here 1913, ordinary professor at Amsterdam. I guess I'll have to erase so we can continue this timeline. So remember 1881. So I guess he's professor by 32, something like that, right? And so one side project he has in those years is I put some key years, key dates for this. So in 1917 they make a first start of it, and in 1922 they found a philosophical group that's a parallel in the Netherlands to the Vienna Circle, the Significische Kring. So this is a philosophical group devoted to Lady Victoria Welby's Significs project, right? So this refers to Lady Welby. The British philosopher was in some ways a founding figure in analytic philosophy, one of the first to point out that there's a problem when you want to define what meaning is. What is the meaning of meaning? I think that's the title of one of her books. And she coins this term significs as a study of meaning. What are signifiers? What is meaning? And it has a strong pragmatic aspect. She corresponds with William James and with Charles Peirce and Russell. And so it's a key connector in that time period. And so a bunch of Dutch philosophers are very interested in those ideas and have a group devoted to studying this. And Brouwer is one of the founding members of this circle, Signific Circle, I guess you could call it. Then in 1918, that's I guess the first Begründungspaper. Let's see, started Begründungsseries. So this is a series of papers in which he lists out his theorems of analysis, and we'll come back to the main events in this next week. Just wanted to put it in time schedule where it is. And then there's a lot of work in intuitionistic analysis until basically 1929. This is when his briefcase is stolen. Briefcase, and I guess a shift of interest accompanies this shift of interests. So a couple of other events closely related. So in 1928, he has the big fight with Hilbert over his editorship of the Mathematische Annalen. Hilbert wants him out. It's another long story, but I guess that makes him wary of being involved in this whole Grundlagenstreit, which Hermann Weyl had also pushed to fire. Hermann Weyl was a
key proponent of Brouwer's Intuitionism at this point, and so contributed to this fight between Brouwer and Hilbert, which we'll come back to later. It's not I won't say too much about it now, but it may be part of why Brouwer stops doing intuitionistic mathematics this year. He has a full notebook, a briefcase of notes that he hasn't any copies of, and those are stolen from him at the train station. He never recovers them, and he's very sorry about this. He doesn't want to redo all of the mathematics, and just shift to more philosophical endeavors after that. Okay. But all of this is before we have any formal theory of intuitionistic logic. All this work, because it's only in 1930, thereabouts, that we get high-tame logic, which is a formal version of intuitionistic logic. So all of this is informal and just done in Brouwer's way of doing mathematics. And we'll read one of the papers of his analysis series, mathematics, next time. Okay. And note, this is also before the recursive functions have been defined. It's before Turing, before Church. So all this predates that, right? This was set at the time. So I guess Turing, 1936 is a big year. Okay, so that's time to get the timeline settled. Okay, I hope that helps also with your understanding of the paper. Okay, so with that in mind, let's go to the discussion of the unreliability paper. So first of all, do any of you have any comments that you had upon, general comments that you had upon reading it that you would like to share? So I mentioned in the beginning, we have these three sections: science, wisdom, and mathematics. What did you make of the first section on science? Anyone have anything to share? Questions about it? What is Brouwer up to in this beginning of the paper?
I guess I did have a question on whether he thought science was where we got the subject-object distinction. That is from the time intuition that he's using here. Science considers repetition in time as the major, or I guess foundational concept. Mm-hmm. Is science responsible then for the object-subject distinction? As he kind of says, separation between the subject and an unreached reachable has become something separate. So I think that's as well to wisdom or religious.
I think he's very clear that that's not what's going on in wisdom. Wisdom is the opposite of this. So I guess you could take it that this separation is peculiar to science, or it's peculiar to the non-wisdom domain. So it's science and mathematics. That's what I think. I don't know the answer to that clearly, but I think if we look at the next page, I guess on religious truth and wisdom, he defines that as that which suspends the splitting into subject and something separate. And we know that in the first act of intuitionism is to have that kind of intuition of the passage of time into something separate. So I think you can say that this separation happens both in science and in mathematics. I think he takes that in mathematics, mathematics is a tool for studying science, but it's not science itself.
I guess I wasn't so much questioning whether he thought the time intuition should play a part in wisdom. Obviously, he says no.
Yeah.
I guess section 2 was so short that I didn't get enough of why I should think that wisdom had no difference between subject and something separate. I can accept that there's no mathematical intellection, but why is there no time in wisdom? That seems odd to me.
Yeah,
He gives a footnote 4, which refers to, you see, 1905, which is the Life, Art, and Mysticism book.
Yeah.
And I guess to really answer it, we would have to read that. We can try to guess. None of us.
I started reading it.
Okay. Yeah.
It was bombastic.
Yeah.
To say the least. Every sentence was like, "Everyone's the worst. We have no idea what we're doing. Culture is the bane of our existence, etc., etc."
Yeah.
It was kind of striking. I was reading it. I didn't read the whole thing though.
Okay, that's very interesting.
Yeah. It was extremely extreme.
Extremely extreme. Okay.
Yeah. It was a very reactionary, very Adam and Eve had it right kind of thing. That was the life. Now we're in squalor.
Well, definitely, there's this Christian idea of original sin, and that we are now doomed. We have to find a way back.
Yeah.
I think that's from the secondary literature I've read about it, is a strong idea, right?
Then does this fit that we don't have time in our wisdom because time is like a modern invention of science?
Is
that something we have to forget to be truly wise or to be closer to God?
Yeah, I think in order to be one, we have to not realize that we are separate from God. We have to forget that. If that's the original sin, then we have to forget that piece of knowledge, right?
I see.
And
so we have to forget object-subject distinctions. We have to forget the cause, which is time.
Yeah.
So time has no place in wisdom.
Yeah, something like that.
Well, just that Augustinian idea, right? God has to exist outside of time. All this stuff has to be timeless.
Oh, I see.
Yeah.
I think if we look a little bit closer in section 1, we'll also get some more clues, because this section has some references to those ideas. I made some notes about it. So there's some clear references to Aristotle, right? And let's see. Yeah, it was. Yeah, so on the second page, the second complete paragraph, Aristotle's conclusions on the constitution of nature are unconvincing without verification in practice. I guess that's you understand what that means? What was Aristotle's conclusions on the constitution of nature? What do you think he means here? Probably something about the classification of causes, I imagine. So Aristotle, have the material, the efficient, the formal, and the final causes. Maybe something in the physics and the metaphysics on substance, the nature of substances. But I guess the overarching idea in this section is that no matter how you look at it, you can try to do some literally armchair philosophy. And if you call that science and you get some idea of your sensory experience, and you try to make sense of that using logic and mathematics, if you take that outside of the domain of experience and try to extrapolate to a new domain, that might not be reliable. And I guess that's the whole thrust of the section, right? Why is logic not reliable in the realm of science? Well, you take it to 100 years later. Well, when we try, we have good experiential evidence for special relativity and quantum mechanics. But if we try to go into a regime where both are really necessary, then we don't know. It's not reliable just doing that logical step, because we haven't tested anything in that regime. We don't know how to combine them. That's my idea of it. Maybe you got a different idea. It's a little hard to say without having the background of the 1905 paper. We shouldn't dwell too long on it. I had some other notes from that same paragraph. The truth unveiled in Spinoza is experienced wholly independently of his logical architectonic. Does anyone want to guess about what is the truth unveiled in Spinoza? What do you think he could be referring to? I don't know for sure. I'm guessing that it's something like Spinoza's idea that again, going back to substances, we were just talking about Aristotle's substances. For Spinoza, he wants to say that there's only one possible substance, and that is God. Right? So and it's Spinoza's God. It's a different thing, but that's my guess. That is something that we experience independently of the logical setup. And I guess I haven't read Spinoza, so I don't know what the logical setup for that conclusion is. But for Brouwer, I guess it's something that you have a religious experience that might tell you that you can be reunited with God without having to prove it. I think that's what he means. Do you agree?
He seems to be associating like any kind of step-by-step construction with like the process of time passing.
Yeah.
And in the wisdom section, he was like, the language of inward turning wisdom appears without order because it can never carry along systems of positive. Like it feels like you're not using axioms to like build up your knowledge, but you're kind of just knowing like, outside time. I don't know. Yeah,
I think that's right. Okay, just to finish this section 1 on science, there's a lot packed in this, the second to last paragraph. So after he mentions Spinoza, he comes to the Accompanies of Kant. So what are the Accompanies of Kant? Do you remember?
Was it on the structure of matter as well?
Yes, I believe that's one of them. So I made a note of it. So one of them is the nature of time. Does it have a beginning or not? And you can argue. So in Aristotle, it's set up as an antinomy. So two things that you can reason your way to, and that are logically contradictory. So one way you can make an argument that time must have a beginning, and you can also make an argument that time cannot have a beginning, and that's an antinomy. The second one is about the nature of matter, that matter must be able to be composed of simple parts that are indecomposable, and you can also make an argument that it can't be that way. Everything has to be its own thing and cannot be composed of simpler things. And the third one is about causality and free will, that you can argue that because causality, you cannot have free will, on the other hand, you must have free will. So again, Aristotle sets up a logical antinomy of those. And the fourth one is the absolutely necessary being, I guess God, whether can an absolutely necessary being be part of time and space, or must it be outside time and space? And I guess Aristotle makes an argument either way. So those are the antinomies of Kant. And again, that's I guess here, if you want to take those as part of science, you have to take metaphysics, I guess, as part of science. But okay, maybe he throws that in there to just give us his contempt for science as a project, and somehow lob that in with the Industrial Revolution and pollution. Okay.
And also self-reference paradoxes.
Yeah. Oh, yeah. So that's the next thing. Yeah, that's in the next paragraph, right? So let's just read that paragraph. Moreover, regarding discourse concerning experiential realities that have been cast on mathematical systems, the logical principles are not directive, but regularities that have after one been noticed in the accompanying language. And if one speaks according to these regularities with no link to mathematical systems, there is always the danger of paradoxes, such as that of Epimenides. And just remind us, what is the paradox of Epimenides?
It's a liar self-reference paradox.
Yes, Epimenides was from Crete, so he was a Cretan, and he said all Cretans are liars. So that's the paradox of Epimenides. Okay, and I guess the idea here is that you talk about something in language, which he takes to be the regime of Aristotelian logic, and when you do that, you get outside of the domain of application that you originally talked about, and you can be led astray. Yeah.
I thought that it was interesting here that the direction is the existence or determination of certain mathematical systems dictates what logical laws we can use. So if you use a logical law without reference to any particular mathematical system, it is invalidated, rather than the other way around. Namely, mathematical systems we know to exist are determined by these valid logical laws.
Yeah.
So it's kind of different from what most people think.
Yeah, I think you could even, I mean, something that comes to my mind is some thoughts about of Quine, that of holistism, that many people say, okay, logic is untouchable. I mean, if we reason ourselves to something that is wrong, then we have to fix something else. Whereas for Brouwer, it's clear that, okay, so logic has to go. Right, so
not just logic has to go, but logic should probably be preemptively destroyed just in case.
Yeah, or at least reconstructed mathematically in some sense, yeah.
Later, it feels like he's trying to like tailor logic to suit the math rather than the other way around. Like, like.
I actually think this reversal is probably the central point of this paper.
Yeah,
It's a central point, yeah.
That logic is based on mathematics, not the
not the
reverse.
other way around.
Yeah.
In fact, its legitimacy comes from mathematics.
I think he says
It's
that
historically
somewhere.
created.
He says that somewhere.
Yeah.
Yeah, I think there are some references to Russell and Frege and some of the problems that were in the air at that time. Oh, okay, so let's,
Oh, I have a question.
okay.
If he was, I assume he was aware of what Frege and Russell were doing. Why does he just keep referring to Aristotle hand in hand with logic?
It's a good question. I don't know a very good answer to it. I think it's an interesting observation. I mean, what were we going to say?
This is before the Principia, right? Or is it not?
It's 1908, so
It is after the
after the
Is that, yeah. Sorry.
Yeah.
Frege is even older than that.
yeah, Frege
Frege
is
is done with that.
yeah, much older.
The paradoxes have not been fixed.
No.
1908 is when Russell gives his type theory.
Yeah, I believe so. And it might have something to do with the education you get in logic at that time in Amsterdam, and I don't know the details of that. Something we could look into and see would he have taken a course in logic, and would that have been only Aristotelian, or would it also have mentioned some Frege stuff? So yeah, I don't know the answer to that. But I mean, if I have to guess, it might be that's the explanation, that he had taken a course from a logician in Amsterdam, and that would have been maybe some course that had been unchanged for 20 or 30 years. That's quite likely, right? I mean, certainly plausible. Someone would have just kept the structure, and so the old style courses in logic would have followed Aristotle, in that you would have been talking about terms. And then you would have been talking about propositions that you could form using the copula. One term is another, or something like that. And then finally, you would have been talking about reasoning, so syllogisms. And that'd be a three-part logic course in the old style.
You might even have had a preference for the older types of logic for this kind of reactionary period.
Yeah, I do.
Yeah, that's a good point.
I have no idea though.
Okay. Do we want to say anything about section 2? Or do you want to go straight to? Well, section 2 is basically just an advert for life art mysticism. And say, okay, I'm not going to say much here. Probably, maybe there was more in the original manuscript, and the reviewer had it tossed out. This was published in a philosophy journal, and maybe there was something else that got tossed out. I should have read the introduction. I think in this new translation,
it says that they don't have the
draft.
The draft material.
Okay, we don't have the draft, so we can. Yeah. No use in speculating. Okay, so let's go to the main thing we want to talk about for our purposes, namely section 3. So what do you get out of that? Or any questions or things you want to highlight? I think there is a revolutionary. I mean, it's not just conservative. There is definitely a revolutionary spirit to this, I think, in the very first paragraphs. Through all ages in mathematics, one has reasoned logically with confidence. Never did one hesitate to accept conclusions drawn from postulates by logic, where the postulates hold. And now he's going to do just that. That is a revolutionary project, if there ever was one, right? Wouldn't you agree? Throughout all ages, people have been doing this, and now I'm telling you, you can't do that. All right, so let's...
I just find it interesting that the reason he thought we should distrust logic and mathematics, the impetus for this kind of idea, at least the one cited, was the paradoxes.
Yeah.
That he was like, almost like, this is what we got ourselves into by trusting logic too much.
Yeah, that's right. That happens just after that on the next page, page 25 of the PDF that I have here. Footnote 6. And that's a whole long list of these paradoxes, right? Yeah. Burali 40, 1897, Zermelo, 1904,
Koenig, 1905, Richard, 1905, Russell, 1903. And he says, for attempts to solve these paradoxes, see, besides the proposers themselves, Poincaré, Mallerup, Schoenflies, but none of these are really solutions, right? These are just attempts as solutions. I guess, when did Zermelo propose his system, which solved things? Do you remember? I forgot to look it up.
1903 or something. No, I think it was 8 as well. He
So-
published the axiomatization.
Yeah.
That's 19.
Yeah, so this is 1904. This is about paradoxes, but not a solution yet.
Right.
Okay, so yeah, that's very interesting. So he has this whole range of paradoxes with no solution yet. So that's why I guess you can see where he's coming from, saying, look, there's an issue here with how we're going about things. Okay. Yeah.
All paradoxes disappear when one restricts oneself to speaking only in systems that explicitly can be built out of the urban intuition.
Mm-hmm. Yeah, that's his program right there.
Yeah.
Built out of the intuition, yeah. Instead of letting mathematics presuppose logic, one lets logic presuppose mathematics. Okay. And so the final part of this section is then just to look at the things you would have learned in that third part of the traditional logic course, how you reason. And so he mentions syllogism, law of contradiction, and the law of excluded middle. And so what does he say about the first two?
They're fine.
They're fine, yeah.
Can we talk about his justification for that?
Yeah, let's talk about that.
The first one,
Okay.
the very bottom of 27.
Yeah.
To begin with, the syllogism reads the fitting of a system B into a system C, and the concomitant fitting of a system A into a system B is a direct fitting of the system A into system C, which is nothing but a tautology, in the sense of Kant, not Wittgenstein.
Yes, that's what that
In the
footnote is D. Is that's by Sundholm and Van Atten. Right? Yeah. So what do you think of that?
I guess, does anybody know what tautology in the sense of Kant means? Is it just a priori unthinkable otherwise?
I think certainly a priori. I don't know.
I guess that's what I'm missing, is that this
Yeah.
is true because it's a tautology. Therefore, it should be accepted as a logical principle. Seems mysterious to me. Some people would say the same thing at the law of excluded middle. It is a tautology.
No, but I think you can see what he's doing. He's interpreting in terms of fittings of systems into other systems, and I think he also has building somewhere. So building, of course, another way of saying construction. So there's an idea that you interpret this in terms of constructions fitting together, and I don't think you can make a similar picture about the law of excluded middle. You can see how he interprets the law of excluded middle in the next 2 paragraphs down, right? But I think this is kind of the same thing that we have in Pierre Martin Löf many decades later.
Yeah.
In one of Pierre's papers, he says everyone must understand for himself, something like that.
Yeah, reading explanations.
Yeah.
Yeah.
I think maybe that's also what Bauer would say to your thing. Yeah, tautology, what? Well, you just have to think about what is a building fitting into another building, fitting into a third building, and it's just you intuit it.
But his whole point is the unreliability of logic into domains that are not mathematical. But then he's using logic to make this statement, right?
No, he's using mathematics. It's about a mathematical intuition.
So the fittings are mathematical fittings.
Yes,
Of
that's how I
systems
take it definitely.
And systems we interpret. I don't know that now.
It's a proposition, I guess.
Okay.
If you have a construction that verifies, I mean, verification is a little bit ahistoric in this case, but that's how I would read it. Maybe we can only read it, I guess, with hindsight. But I would read it as that we have a construction that that's a verification of proposition A, or that A implies B or something like that.
What makes an intuition mathematical instead of logical or some other intuition?
So that is the distinction between the language and intuition, right? So for Brouwer, remember language, I mean, now we would say something completely different. We have a linguistic turn in philosophy and so on. We can talk about that too, if you like. But for Brouwer, definitely, mathematics is not language. And intuition is pre-linguistic. And you just intuit it. And if you then want to communicate that to someone else, then you get in trouble, because then you have the unreliability of language and the impossibility of really connecting to other human beings, and you're better off just sitting in your cabin by yourself and intuiting things.
So maybe we should touch this one a little bit. But when I read this, I wondered if these references to intuition were anything other than shibboleth. A lot of people who spend lots of time working in set theory sincerely believe that there's a pre-mathematical or pre-linguistic idea of set that's already in everyone's mind.
Mm-hmm.
Or maybe my intuition tells me that I should already have an unrestricted comprehension axiom, which already gives you all of these paradoxes. If my intuition tells me that thing is true, in order for that clash to happen, then you actually have to have two mathematicians talk to each other, right? Which might be forbidden. It was unclear to me what, if any, the criteria there is for determining whether something is intuitionistic, aside from the things that personally Burgess Brouwer likes.
I think we can definitely say something about the axiom of separation, because that's I think he would say that's an inherently linguistic thing. You have to, I don't know how I would say it. I think it's a good point. I don't know what Brouwer would say to this. We can try to look at the text. But it is a problem for him, right? If he wants to say that you can't communicate these intuitions except in a very flawed way, why is he spending so much time writing to us about it? I mean,
So, no, he doesn't want any language, doesn't want any logic. So when he says tautology, does he mean that the negation is like inconceivable to somehow anybody, or really just himself is what he's concerned with?
I think the truth is directly accessible through intuition.
Okay.
I think is.
Yeah. In his later writings, this is before he has any ideas of the creating subject and things like that. So I think maybe later he writes something about this trans-subjectivity, if you want, or how we can move from our individual intuitions to the ideal mathematical creating subject. But at this point, I don't think he has that. So I don't know if we can understand it better without going in. But we already have some good points about definitely this turning logic. The relationship between logic and mathematics is turned on its head. And what is the nature of this intuition? It's a good point. We had his description of the first act of intuitionism before.
Is this intuition maybe something that happens before any kind of like sequential like deductive steps? So it's like separated from like the time flow that he was talking about earlier. It's something like below that, something that happens like, I don't know.
The way I understood it, it was that it was the abstraction of the intuition of time. So it's the contentless distinction from the passage of time from one moment to the next, something like that. That's the intuition, right?
Okay. No, because he keeps on saying that, because if his distrust is generally in something that's like linguistic, and we're viewing logic as like a language of like deductions, where you go from like, where you proceed from like general axioms that you move forward, then his distrust would be anything that isn't immediately conceivable, right? That you need to get to using certain steps, which he seems to associate with time. And so therefore maybe his idea of intuition is sort of like his idea of wisdom, in which I don't know.
I think he does want to take mathematics to be outside of wisdom and to rely on the basic separation where not everything is united, but you have a separation, but you abstract that into the most basic separation you can, something like that generates the numbers, or we have that idea of intuition of time giving rise to the natural number sequence, and then other buildings, construction, somehow you can build mathematics or at least arithmetic, and then later on analysis out of this intuition. The problem comes when you want to then say do logic, and that's where he says instead of having logic just be universally valid, something we take on faith, we do that as an afterthought. We look at how we're doing these languageless mathematical reasonings, and then we try to describe them in word because we have to write papers and theses and so on. And that's when you can do logic. You can do logic when you're trying to put things down in language. You're describing your buildings, your constructions, and the principles that occur at that regime, and you justify them through as another act of mathematics.
So then he seems to say that mathematicians are able to intuit the results before they're able to formally derive them.
Yes, absolutely.
Which I don't know, just doesn't seem to make a lot of historic sense, considering many of the results that just didn't seem to be intuitive, like throughout time. Like there have always been results that people are just like, what's going on? I don't know. It doesn't seem to work historically.
Like when a result is presented to the community and is thought of as being unintuitive, it's unintuitive to the people who to whom it did not occur.
Yeah.
Right? So maybe you need the spark of intuition before you can produce. The first person who produces the proof can produce it.
Another way to think about it is that for Brouwer here, the proof is part of the intuition. That is, the proof is not a linguistic thing. The proof is your intuitive proof, but it's still a proof. That's a real proof. The proof you build in your mind, and that you find absolutely convincing, and that if you were the creating subject that didn't make mathematical mistakes, that would be a perfect proof. But that's still a pre-mathematical thing. And then later, when you want to convey that to someone else, will you try to
Pre-logical, right?
Yeah, pre-logical and pre-linguistic.
Okay.
Yeah. So one has a certain kind of intuition that's completely reliable, and if that happens to contradict logic, then one should just change logic. Is the idea?
I think that's the idea. Except maybe he would allow for your intuition not to be completely reliable, but still typically more reliable than your language. So if you can try to redo your intuitive proof or your intuitive construction, your pre-linguistic somehow, whatever that means. I mean, but now we are so used to thinking everything is language, everything is text, right? That it's hard for us to get into this frame of mind where the mathematical reasoning is non-text.
Okay, so because I mean, the thought, of course, occurs to me, well, what if I'm completely delusional? But if I'm not communicating my ideas to somebody else, I guess it doesn't matter.
It would still matter, yeah. You would still have to go over it and check yourself.
Okay.
And somehow we just have to imagine that when you do that reasoning, it's somehow a non-linguistic phenomenon for Brouwer, at least in Brouwer's conception. That's how I think we should take it. All right, so that was
it seems to me that even by the end of this paper, the idea of what the intuition is still very much open.
Well, it seems unlikely he's going to write down the definition of the intuition in language, right?
Yeah.
So you have to be a mathematician to know it, or if you know it, you're a mathematician. Because you can't. It doesn't seem like you can communicate your intuition.
We just try to describe it, right? But at least later, and also in the dissertation, I don't have the excerpt, but I mean, he tries to say something about this, the constantless truity, that we get from the intuition. So he tries to paint a picture in language, and he hopes you get the idea.
Sounds like it's a very long-winded way of saying you either get it or you don't.
Okay, I don't think we get much closer to the intuition at the moment, but we can at least get closer to the other two principles of Aristotelian logic that he discusses here. So we somehow discussed the syllogism, and that's basically composition of functions, as we would say nowadays. And he says that, okay, that's something you can do. And then what does he say about the principle of contradiction? I think that's just something, just a statement, right? Nor can the principle of contradiction be assailed, completing the fitting of a system A in a certain way into a system B. Okay, so B, you can, I guess A proves B or something like that. And at the same time, being blocked by the impossibility of that fitting, those exclude one another. And so that's just the way it is.
So is it, if you try and fail, you can't do it?
If you know you can and you know you cannot, then those just can't happen at the same time. But
So
it
like
not A and not A.
Yeah, so not.
Yeah, that's right. So it's the principle not A and not A.
So see, I do something like the principle of contradiction is justified as linguistic or logical move because every instance of us are implemented in the principle of contradiction is one where we can interpret it as blank. It's like every time we're using a mathematical system, we can think of it in this way.
Yeah.
It's not saying here's a particular mathematical system that's justified.
Yeah, that's right.
Abstracting from that.
Yeah, he's abstracting from in the mathematical realm of having these buildings or constructions and having one building fitting inside a system or fitting inside another building.
So it's supposed to cover all applications of the principle of contradiction.
Yeah, but I wonder if he takes this to imply ex falso, because that would be another step beyond this. It seems okay. It's fine that you say okay, these two things can happen simultaneously, but does that fact in itself count as a building that fits into any system? Would be the question.
So ex falso is still valid in intuitionistic logic.
Yes.
And negated ex falso is still valid in minimal logic.
Negated ex falso?
This is if you have that you can from the uncertainty you can prove the negation of every statement. But anyway, it's a hard result to get around.
Well, we'll talk about in the second half. We'll talk about the Friedman A translation. I guess that gives us somehow a way of thinking about this. So we can come back to this point later. But I just thought it's interesting that the text here. I don't know what he meant by the Aristotelian contradiction rule, but if it were to imply ex falso, I don't think it's much of an argument that ex falso is reliable in intuitionistic logic here.
How would you formulate that in terms of systems, though?
Hmm?
How would you formulate ex falso in terms of the way he's formulating?
I would say that if you have what he's talking about here, so you have the fitting of A into B and the impossibility of fitting A into B, then you can fit that thing you just had into any C.
But then
Wouldn't that be the?
If we take the conditionality true if the premise is false, but maybe he doesn't read conditionals in that way.
Yeah, it's before Kolmogorov and Heiting discussed the nature of problems and intentions and all that. So we don't know how he thought about implication at this point.
So the idea would you would need to have a construction that would tell you how to use one to block the other one, and somehow this would be able to fit into anything.
Yeah.
And so that happens to maybe come out in the Heiting algebras, and so it works in intuitionistic logic. But I think the question is whether or not Brouwer would have wanted this, conceived of this in terms of the purely solipsistic mathematics, right?
Yeah.
Okay.
Maybe it'll become clearer if we read some of his mathematical texts where it would be needed to have an argument by ex falso, and then we can see whether he uses it or not. Maybe next week we'll come to that. I just thought it's an interesting point to note here that just 2 lines and that's it. Okay, so now the main act of this thing, we can the principle of the excluded middle. And so this is the main innovation of this paper. The question of the validity of the principium tertii exclusi is thus equivalent to the question concerning the possibility of unsolvable mathematical problems. Does he give really an argument for that, or is that where does that come from?
It seems to take the burden of proof lies on the other side. So it says, for the already proclaimed conviction that unsolvable mathematical problems do not exist, no indication of demonstration is present.
That's right, but the interpretation, let's say that to have the law of excluded middle would require you to solve every mathematical problem. I guess that comes in the lines before that, right? So let's just read it. What does the law of excluded middle demand? This demands that every supposition is either correct or incorrect. So I guess that we can take that as something that Aristotle would have agreed to. Okay, what is that mathematically? Because he wanted to interpret logic in terms of mathematics, right? So every logical statement has, in the realm of mathematics at least, has to be understood mathematically. That every supposed way of fitting in a certain way of systems in one another, either the termination or the blockage by impossibility can be constructed. Right? So, yeah, it's clear that, I guess it was also clear of the preceding paragraph that his idea of negation is a construction of an impossibility. And so he comes to this interpretation that excluded middle means that you can either construct the fitting of A into B, or you can construct the impossibility of fitting A into B. Okay, and that's why it comes down to, are there unsolvable mathematical problems? And then exactly as you say, now the burden of proof is on the other side. Those who want to assert the law of excluded middle will have to come up with a construction that does that, a way of solving every definite mathematical problem. And there are some...
do you have to come up with a solution to every problem, or come up with a way to prove that there is a solution?
You have to come up with a construction that would work for every problem, I guess. Yeah, we can see it in the text a little bit later.
I think any argument that was not a construction for giving constructions would be unsatisfying to Brouwer, right?
So one would need a single construction that you could use on anything to determine its truth.
Maybe a finite family.
Yeah.
So I'm hearing from Egbert that he can't quite hear everybody in the table, even though this is supposed to have an 8-foot radius. So I'll try to repeat a little bit more. So the discussion now is what does this really require, this solution of every mathematical problem? I think there are some clear clues in the text. So the first one is right after the pronouncement of that this interpretation of excluded middle. For the already proclaimed conviction that unsolvable mathematical problems do not exist, right? So I think this is very interesting, because this is not it's not quite the double negation, right? Because it comes to that later. Well, let's have a look and just go through it. So, let's just finish up this thing that he says that other people have proclaimed the conviction that unsolvable problems do not exist. And here he gives a reference to Hilbert's 1900 speech at the Congress of Mathematicians, right? And if you remember, we already talked about this last week. Paul and Emile Dubois-Reymond had a philosophy of mathematics and science in which there are just some things that we must expect us forever to be unknowing of. So there will be something that will be ignorabimus. And Hilbert reacted very strongly against this, and the whole thing in this 1900 address. I mean, Brouwer is not there, so if he has a philosophical itch to scratch, it's against Dubois-Reymond, and it's against this idea that there are unsolvable mathematical problems. And he says, okay, that's not the experience of mathematicians. The experience of all mathematicians is that when we have a problem in front of us, we will work until we either prove it or disprove it. Right? That's what something like what he's saying. So that's what that footnote is about. Okay, so let's try to get closer to what he would take to be a positive proof or construction of the law of excluded middle. So he says we can do it for certain finite discrete systems. Then it's okay. The investigation into the possibility or impossibility of a fitting can always be terminated and leads to an answer, whence the principle of excluded middle is a reliable principle of reasoning. So he takes that argument to be a construction that's good enough for finite domains. That if you have finite domains and you can check whether systems fit or do not, and you only have finite many things to check, then it's okay. And then the construction is exactly that. You just try everything, and either you found a fitting, or else the very fact that you tried everything and you failed is a construction of the impossibility of such a fitting. That should make it clear what kind of thing he has in mind for a positive argument for excluded middle, because he gives it for this domain.
So if you wanted to do this in general, though, you would have to have some criterion for what constitutes a problem, right?
That's right.
So you just have to have an intuition for what a problem is that you can describe.
That's something we'll come back to again. I guess it comes down to notions of predicativity, or impredicativity. Can you once and for all circumscribe all possible statements or propositions? And couldn't you then, I mean, he references Richard's paradox. If you could do that, then you can diagonalize out of it. And so that's, I guess, some indication that even if you get better and better, and if you have larger and larger domains of which law of excluded middle, he still wouldn't be satisfied, because you could still you don't want to cut off mathematics and say this is all there is to it. There might still be new domains where you don't know whether you can do this construction.
But I think more fundamentally, even if you could actually do that, for Brouwer, this would still be an a posteriori truth.
Can we say a little bit more what do you mean?
So if you're a conventional logician, you just look at the law of excluded middle and you say, yes, a priori true. We don't need a model to show that this works. We don't need to say, look, it worked really well in the finite case. We can probably guess that it also works in the capital case. And then here's an argument that gives up to a certain cardinal. You just say, no, this is obviously true. This is what truth means. Whereas Brouwer is leaving the possibility open that it's true, but he's not leaving open the possibility that it's a priori true.
Do you mean by that only that we have to check for every new domain whether it's true?
I suppose so.
So the discussion is now about what Brouwer had would have any ideas of a priori versus a posteriori about logical principles. Even if we did this afterwards, would it count as a priori or not? And I don't know what he would have thought about that, but I think what comes to my mind is that what Per Martin-Löf later wrote about this very issue, saying that we can, in logic and constructive mathematics, we can have a lot of truths that are synthetic but a priori. So they are a priori in the sense that we can come up with them through our intuition or pure constructions. They're not depending on sense data, but they're synthetic. We have to really put them together. But once we put two and two together, that is still a priori for, even if we have to
reach for a calculator, I guess. We can still check it. Does that make sense?
Okay, right. So maybe the split is the analytic synthetic split.
Yeah, maybe that's a split.
Yeah.
Yeah, let's think about this counterfactual that say the Hilbert's 10th problem on Diophantine equations had an algorithmic solution. Right? That would be a great thing, or say someone tomorrow comes up with a proof that P equals NP with a very good algorithm that runs in time into the 1.1 or something like that, right? Then now we can know, whether any mathematical problem has a short proof or disproof, and many things are very great, right? But that would be a synthetic control, something that would be a priori but synthetic. Okay. Let's see if there's anything else we want to say about this paper. There's an indication of his cardinalities, right? So they're finite, the denumerably unfinished, and there's this indication that talking about ordinal numbers or cardinal numbers, that you can't decide now whether cardinal is finite or not. That's his first indication that probably the law of excluded middle is not reliable in the case of Cantor's set theory.
There was one thing that I thought was notable, is in the middle of that paragraph where he's talking about the infinite systems.
Yeah.
He says, right after the footnote, namely by observing properties, that is, fittings.
Mm-hmm.
And that made me go back to read other things.
Yeah.
With fittings as as properties.
Yes.
And unless I think of it as extensions of like predicates, I have no idea how to read this into the law of non-contradiction and hypothetical syllogism. It doesn't seem to work.
So this is the question is about this notion of fitting and a property, and it goes back to what we were saying before, and it may be prefigures, or maybe it's an early indication that he had something along this in mind, that what was later the proof interpretation of Heiting and Kolmogorov and I guess Husserl, that a predicate property is about an intention that you can fulfill. It's about a problem that you can solve, or it's about a system that you can have a fitting into. And that is what it means to be a predicate. That something is a predicate of X. If X has that property, that means that there is you can solve the corresponding problem. You have a family of problems, and you can solve that problem for a given X.
So you think his primitive is fittings, and he's saying properties are just fittings?
Yes.
I was kind of reading the other way around, saying, "Oh, I know what properties are. I can't wait to figure out what fittings are." Oh, I think that helps. No, that doesn't work.
Yeah, no,
properties don't work.
My guess, and that's only because we like most of you probably, I only know the later stuff first, and now trying to go back and see where does it come from, and I interpret it this way.
That does help, though.
Okay.
Bringing properties closer to fittings.
Yeah. Yeah. So properties are described in terms of fittings. Okay. So it's not yet reliable. Let's see. Then we have the proposition about either finite or infinite. And then we have the last page. And then we have a couple more examples about what he means, right? So is there in the decimal expansion of pi a digit that occurs enduringly more often than all others? Do there occur in the decimal expansion of pi infinitely many pairs of equal consecutive digits? And so on. And likewise, it remains uncertain whether the more general mathematical question is in mathematics the principium tertii exclusi unconditionally valid, has a solution. And there's a footnote. One should therefore in mathematics distinguish the propositions that are usually taken to have been demonstrated into correct and non-contradictory ones. So this again, I think we skipped the point. We skipped the point where he argued that you cannot. So that's this paragraph that starts, so that in infinite systems, the principle of excluded middle is not yet reliable, is as yet not reliable. Still, one can never, in unjustified application, be blocked by a contradiction and thereby discover the groundlessness of one's reasoning. So even though it's not reliable in the sense that you can
have a fitting one way or impossibility of a fitting, if you use the law of excluded middle, you cannot be blocked by a contradiction. And that's I guess he's arguing there that not A and not A. So okay, I think that's an important point that he has that argument there, and then he says that's why he has this separation into the correct and the non-contradictory ones. The ones that use law of excluded middle, they are non-contradictory, but they're not yet correct. So I guess that is the first indication of this distinction in proof. Do you have a constructive proof, or do you not have a constructive proof? Okay, so he calls the constructive ones correct. He gives some indications of some mathematical theorems that are non-contradictory, that is used using non-constructive principles, as we would say today, that a closed point set line can be split into a perfect and a denumerable set, as one example. Okay. And then, so the summary in wisdom is no logic, because we don't yet have that. We don't have language. We don't know all about that. In science, logic is often, but not enduring, the efficacious. I guess you can try to make predictions, but you have to test your predictions to see whether they are still valid in the new regime that you use logic to get to a new prediction. And then in mathematics, it is not certain whether all logic that is including the law of excluded middle is permissible, and it is not certain whether it can be decided whether all logic is permissible. So it gets to this question of, could anyone prove that you can solve all problems? But not to Evan's question of, does he really have an idea of something that would circumscribe once and for all of logic? I don't think he has that, but he puts a question there that until someone has a convincing argument, I'm going to not use law of excluded middle, and that's his program. Okay, so that's his paper. Yep.
I have one sort of question out there as well. The discussion of wisdom seems very orthogonal to me to the rest of the paper. So, like, in no way does the rest of it rely on the fact that wisdom is no logic. I was wondering if anybody thought they saw the connection between the discussion of wisdom and the discussion of science, or there was like some way in which that played a role in the rest of the paper. To me, it seemed like just entirely.
Okay, so the question is about what's the connection between the wisdom section and the other sections? And I just take that to be, that's his view of the world and the view of intellectual pursuits, that you have the thing you do in your cabin when you try to remove the separation between you and God. That's one area of life, and that's important to him. Another area is when you do science in order to cope, because you need to have bread on the table and so on, and that's another area of life. And then there's mathematics, which he was also interested in, and that's how he sees the world. Those are the three topics that you could possibly be interested in. Does anyone have any other?
I think it serves as the extreme degree of the unreliability of logic, right? 3 degrees. Okay. Completely no place in wisdom. You have to be freaking careful in science because you have to test these things. It's empirical, who knows? And in mathematics, you have to be a little less careful, but still a bit more careful because it's a linguistic artifact on top of intuition. Okay. So I think of it as a degree.
Yeah, so a matter of degrees from wisdom to science to mathematics. Okay, with that, we'll take a 5-minute break. I'll leave the broadcast running, and we'll start again in 5 minutes.
Art and religion in this world are only grand morphemes of this truth. The yearning for a better life is lulled into sleep and reduced to a state of torpidity. It is not easy to show more of oneself than belongs to a restricted life, one's head, one's intellect, the actions that have a place in society.
So that is significantly more than I think you're correct.
It's really heavy. Everyone except the Redeemer is a caricature.
So,
people have dragged each other down with them in the misery of their culture. Just so sad. Everyone's earthly life ends in great dissatisfaction. Death is the collapse and final ruin of the system.
Maybe a little bit closer to timekeeping.
Do we talk about the meaning of that passage?
Yeah, I think we did talk about that. So anyway, we'll put this on the broadcast anyway. So Colin asks about this passage about the paradox of Epimenides, and his diagnosis of the problem. And we said something that it comes from trying to reason linguistically, using logic about the linguistic structures, even when you don't have any underlying intuition of what it is that you're talking about. So I think he takes that being a liar and being a truth-sayer that's something inherently linguistic, and you can't have a mathematical intuition about it because it's linguistic, and hence you can't apply logic unthinkingly in that case, and that's why you can get into paradoxes like all Cretans are liars if you're a Cretan.
So that makes sense to me, but I'm not sure if I can directly get that from what he wrote. Because I'm not sure what he means by regularities in the language that accompanies mathematics versus language of mathematical words that does not accompany mathematics.
Let me just find the what page was it on? Here. Right after footnote 8, right now. So, okay, the regularities in the language that accompanies mathematics, right? Okay, so here he's talking about we build up a language to talk about our mathematical intuitions. Okay, this is how our kind of a meta-mathematics. We're talking about mathematics, but we're making language out of that. And that's the language.
So this is the sort of, he thinks we can't perfectly communicate, but we have some sort of idiom that we
Indeed, because we can now, that's now a new kind of mathematics, and we're trying to communicate that. Just as we will communicate the mathematics itself, we can also try to communicate our thoughts about mathematics, which are mathematical in nature. I guess that's a good point. We should come back to that later. But okay, so that's that. But we extend it over a language of mathematical words that does not accompany mathematics. So that's the second part of the sentence. So here we build up this language to talk about mathematics, and now we have some mathematical words, but we now extend them beyond their original domain of application. And that's, he says, what's going on.
Okay.
So we may even have to find what it means for a mathematical proposition to be true, and thus we have a notion of truth. And that's then a mathematical word. I guess that he takes truth in this case to be part of the mathematical language. But here it's extended.
You're just having an amazing time with that text, aren't you?
He says it's extended to something that doesn't have accompanying mathematics. I think that's how you would say. That's why it's in there.
Okay.
But the reason why people don't disagree on logic is because it's a small, unimportant part of the brain, which forces their attention in the same way. This is so good.
Jeez.
Okay, Todd, to get to your question, I don't know what Brouwer said about ultrafinitism. Maybe I'll look it up later.
Was ultrafinitism around before? I thought that came out in the 50s. Was that around?
Yeah, I don't think it was around then. Okay. We already talked about last time that.
What exactly does Brouwer talk about?
That the
mysticism, other than sort of like a general.
The constructivists and the Russian constructivists had an idea of things should be feasible, but they didn't have that modern notion of complexity theory or anything like that. So it's something definitely later than that.
Okay. Because surely he wouldn't have agreed with me.
Really sad.
Right.
Yeah.
And like entertaining?
It's me.
Oh yeah.
He says,
I see.
This corrupt world, as you now recognize, only exists because of its very corruption, its deviation from the path of rectitude. A world of righteousness now seems to be you as contradictory as your own mortality. Folly and misfortune equally balanced, they govern the world. Any struggle for better order is just one drop more in the ocean of folly.
Can you? I think Brouwer's too mad, too angry to be a hippie.
Yeah.
Oh, wait. Oh, yeah. So then you will be reconciled with your world and not try to change it. He does not want you to change the world at all. You will work, eat, sleep, and travel in your world knowing your inevitable karma. It is precisely this awareness, your humility, which will help you grow into the fullness of the Lord, and will protect you from desires and fears which are not part of the task given to
And then it completely didn't score.
Yeah.
Ridiculous, too, is the use of language when there is an argument and people try to come to an agreement by means of reasoning.
Hey, Brett, I'm glad you like it.
Yeah, that is ridiculous.
I think it's
No, this is
really great that you're in
the symbolic logic journal. It's 30 something.
Oh, this is
Yes.
It is. It's 40 pages.
It's really great.
So, like,
Okay.
I thought they did this.
Programming language.
So this might come in parts though. Maybe that's what I'm saying. Or maybe this is a set selection. Chapter 1: The Sad World.
It's just going to be
Good start. Yeah. Chapter 1: The Sad World.
That's awesome.
Chapter 3: Man's Downfall Caused by Intellect. It's just so good.
Are you a fan? Are you a convert?
I am. How can you disagree with this? It is ridiculous to use language when there's an argument. People try to come to an agreement by means of reasoning.
He has some terrible things. I mean, I remember some quotes just around that passage where he says, if you want to know how terrible arguments are, just think about arguing with women. You can never do that, or something like that. It's like it's very denigrating.
Of course, an argument is valid.
Comical is the language of conversation between boys and girls. In their case, there is already a harmony of will, and language is completely superfluous. Indeed, its only purpose is to hide this harmony of will, serving modesty and shame, which dare not face it openly, to mask seriousness behind jokes. The worst and most disgusting case of such uncivilized intrusion is that of associations which members, male and female together, study the problem of sexuality. It's not the most disgusting thing. The association in question in Amsterdam University calls itself ethos. It represents the greatest obscenity that one has dared to show in public. So exploration of sexuality is the worst thing possible.
So we can kind of see why Heiting might have been embarrassed to have this in the collective. So it's certainly not something to be proud of.
Organize a book reading.
Yes.
It's only 40 pages.
It's only 40 pages?
Gilbert Gottfried should do like
Every sentence.
Gilbert Gottfried.
prove that Joseph Arimathea was the
Slices up and
yeah.
50 hit the ground.
Okay.
Like, I mean, he wasn't like useful in hiding in a cabin. He was inside his house.
Yeah. Okay, should we close the door again? Maybe.
Was he in a static cabin?
It's really fast.
Fasting and like.
Okay, so to everyone following along, we will now go to the second section of today's meeting, which is about some formal logic and some meta-mathematics of Heiting arithmetic. So as I said, we're jumping in time. We're jumping to stuff that happened certainly 50s and later. But it's a good good thing to have some idea of before we jump into Brouwer's mathematics next meeting. Okay, so I just want to ask you, maybe if you have any questions, anything particularly you would like to discuss. Otherwise, I'll just try to summarize the main points I think we should have out of this. So in chapter 2, that wasn't directly part of the reading, but probably if you were a little confused, you would look back into chapter 2. And a lot of logical calculi are defined there. So there's a calculus of minimal propositional logic, the MPC. It's a calculus of intuitionistic propositional logic, IPC, classical propositional logic, CPC, minimal predicate logic, MQC, intuitionistic predicate logic, IQC, and classical predicate logic, CQC.
So I hope you've all seen those before, and so whenever they refer to those, that's what they are. Maybe you hadn't seen the stuff about e-logic, kind of a logic of partial terms, but not Bison's logic of partial terms. It's a kind of free logic where variables do not necessarily denote, but they also have a variant where variables do denote, E+ logic. And they discuss the strictness axiom. So basically, I guess Bison's logic, the Bison-Pfefferman logic, is E+ logic plus the strictness axioms. And those variants come in handy in certain times and certain places. But yeah, any questions about any of that? Not at the moment. Yeah, so Egbert asked if we can set up a channel for running commentary on the broadcasts. I don't want to worry about that now, but if you guys can figure out something out, then post it in the comment section. That'll be great. Okay, so what else happens in chapter 2 that we should know about? We should know about the Gödel-Jensen negative translation, but that comes again in chapter 3. And there's a section 2.5 on cryptic semantics. That's handy if you want to know that something is not derivable, right? Okay, so what we were supposed to discuss, we're starting with section 3.1. It's just good to know what are the primitive recursive functions and primitive recursive predicates. And I hope that's familiar to most of you. Otherwise, now any questions about that section? Okay, let's just scroll on. Then section 3.2 is the formal system of primitive recursive arithmetic.
I guess I do have a small historical question. The definition of primitive recursiveness, I know like Gödel had that, but do you know like the first time that this got formalized and standardized?
Not. The question is, when was primitive recursive functions first formalized? And I don't remember offhand. Do you, Frank? Frank doesn't remember offhand. No, we'll have to look it up. Might have been. It's probably Gödel around the same time that he did the general recursive functions. I imagine it's the same paper, 34. That's my guess. We'll have to look it up.
Oh, you mean like a Princeton lecture?
Yeah, because that would be so. That's a natural way to get to his notion of mu recursive functions, right? You set up the primitive recursive functions, and then you add mu recursion.
Right.
But that's a guess. It might have been historically a little bit different. Yeah, the main thing is that we know that a bunch of functions and predicates are primitive recursive.
I'm just looking up. Wikipedia says Skolem in 1923.
Oh yeah, that's right. Frank, this reminds me of Skolem 1923. Skolem had a discussion on how you could do arithmetic, and that I guess in an infinitist way, and so that's I guess that's very clear that you have primitive recursive functions there. As I remember, I've looked at this once. Many people say that he only does primitive recursive arithmetic, but I actually think that his argument for it does also justify Gödel's higher order primitive recursive functionals, but maybe something we can look into if we once we get to that. Yeah, so Skolem was 10 years before that. Okay, section 3.2 is about PRA. And I guess the main result of that section is that, so here we take PRA to be a propositional theory with open propositions about the primitive recursive functions. So you make primitive recursive equations, and you can do propositional connectives. And then the main result is you can use reasoning with the law of excluded middle in this domain, because you can decide the primitive recursive equations. So anything you can derive with the law of excluded middle, you can also derive intuitionistically. So for PRA, it doesn't matter. That is proposition 2.9. Right. For all A, PRA proves A or not A. And then, so then the main object of study in this section is in section 3.3, Intuitionistic First Order Arithmetic, HA, or Heiting Arithmetic. Okay, so now I'm just going to open this up. Any questions about this section so far? So yeah, one of the first points is that if you have arithmetic, then you can define disjunction. So just define disjunction as there exists an x, either x is 0 and a, and x is non-zero implies b. So that has the same rules, that verifies the rules for disjunction. So he checks disjunction introduction rules and the disjunction elimination rules in the natural deduction style. So that's a good thing to know. That sort of justifies why when we get to explicit numerical definition, if you have that, then you must also have the disjunction property and something like that for any system that's strong enough to do this argument. Okay. I'll see if I can join. Okay, so then subsection 3.4 is the relationship between Peano arithmetic and Heiting arithmetic. And so via the Gödel-Gensen translation, you have this important result that PA proves A if and only if HA proves the Gödel-Gensen translation. And furthermore, classically, that is in PA, A and AG are equivalent. Right? So this tells us that somehow you can embed classical arithmetic inside Heiting arithmetic. And it's also the important second part, that if you have a formula that doesn't contain any disjunctions or existential quantifiers, then probability in the two systems are the same. Okay. Then there's this discussion of the primitive recursive Markov's rule. That's a pretty neat argument here. We'll talk about it later when we get a more the full Markov rule. So I guess we skip this argument right now. But you can already get primitive recursive Markov's rule just from this discussion. Then the proposition 3.5. There we have to know what it means to be wiping and isolating. I guess it's not so crucial. This is in the discussion of the negative translation. There's a whole bunch of, the whole accompanying discussion of when you can imply something. You have a compound formula and you do the negative translation of a subformula. When does that imply the same thing where you don't do the negative translation and vice versa? And so by carefully analyzing those cases, we get this result here. And let's not go further into that now. We get a better argument in the I guess the next section, or two sections down in 3.5. So then there's some principles that are not valid in Heiting arithmetic, including importantly the least number principle. So even though, yeah, any questions about that? But on the other hand, not least number principle is provable. Gives two proofs. Okay. Then it's of course important, particularly for when we do the recursive mathematics, that we can formalize notions of algorithms inside arithmetic. And I take it that you have had a course in computability and algorithms before. So just gonna say, okay, skip that over and say we can code that up. But it's good to know the abbreviations they use in the book. So TREC is the total recursive functions here. Of course, we're going to use the cleaning predicates a lot, the T and the U. And T is the some code for an algorithm on some input. This is a computation that the computation sequence for that pair of algorithm and input, and then the U takes such a computation sequence and extracts the results. Okay. So let's go to the main section. The main action here is some meta-mathematics of Heiting arithmetic, subsection 5. Okay, so the first part here is Friedman's A translation, which gives a very nice proof of closure under Markoff's rule. So Markoff's rule in here, in this case, is if you already have proven for all x, a of x or not a of x, and you've proven not exists x a of x, then there must also be a proof of exist x a of x. Okay. And so the A translation is this neat device. You just define it by recursion on the formula. If for a prime formula, you say P or A for some fixed formula, and by Falsum, you say the A translation of Falsum is A. And then it's compositional with respect to connectives. And then this lemma 5.3 is the main results. If Heiting arithmetic proves B, then it proves the A translation of B. And it's not hard to prove once you have the idea. And then you get this result bullet point 3 that for any term, if you prove not exists x t x y 0, then HA proves exists x t x y 0. And it's just a result of this observation. Excuse me. Then 5.5 is closure under independence of premise. So if Heiting arithmetic proves not A implies exists x B, then it proves exists x. So independent of the evidence of not A. Exists x, not A implies B. X not free in A, of course. And here's a very neat proof using the A translation applied to not A. So I think it's pretty cool. Hope you enjoyed it. And then 5.6 discusses the disjunction and existence properties. And these are properties that many constructive systems have, though not all. And but I mean, they're certainly very good to have. So the disjunction property says that if you've proven a disjunction, A or B, then there is a proof of A or a proof of B. An explicit definability, if for numbers here, this is a theory of arithmetic, so if there exists a number x, such as A of x, then, and you prove that, then you also have a proof for some numeral of A of n. Okay, so those are certainly important principles of formal constructive systems. And as we said, because disjunction can be coded in terms of the existential quantifier, if you get one, you often get the other. So let's see. We prove them here, not using realizability. We'll talk about other proofs using realizability later. Here's the proof using the slash relation. So there's some discussion in notes that this is a proof technique developed by Kleene, but Axel had some refinements to it. And there's an exercise that you prove that the Kleene and the Axel slash relations are somehow equally good, but the Axel one is just a little bit better. So let's have a look at this definition of the slash relation. So it's a relation between a set of sentences and a sentence, right? Just like I have the sequence. So gamma slash A means if A is a prime formula of Falsum, that gamma derives A in Heiting arithmetic. And then gamma slash A and B means both that gamma slash A and gamma slash is B. And gamma slash is A or B means gamma slash is A or gamma slash is B. Okay, then always the main case, and what you have to do for these things in is the case of implication, and this is you'll see when we get to realizability that there's many parallels with realizability with truth. Here the condition is, okay, we have the formal implication, gamma slash is A implies B, means if gamma slash is A, then gamma slash is B. But moreover, you must also be able to derive gamma proves A implies B. Okay. So that's the main trick. Otherwise, it's just you see it's just compositional in terms of the formulas. But there's the key thing you add in. Not only do you have that implication, but you also have gamma proves A implies B. And then the other things are compositional. So the quantifiers, gamma slashes for all x ax. So just like the implication, you have you must prove in gamma for all x a of x, and furthermore, gamma should slash A in a numeral for x, and gamma slashes exists if gamma slashes some instance, numeral instance. Okay, so the main property is that if gamma slashes A, then gamma derives A, and furthermore, you can, so the next lemma is you can substitute a closed term for its evaluation. And finally, theorem, if gamma slashes any element in gamma, then and gamma derives A, then gamma slashes A. Okay, so that's where the main work is in this theorem 5.9. So you check you do it by induction on derivations, and so here they use a Hilbert style definition of derivation, and you just check all the axioms, and you check modus ponens and generalization. And some of them are left to the reader. Maybe we should, I don't know. If we want, we could do one of the ones that are left out. But then it's a direct corollary that HA has the disjunction property and explicit definability. Right? Because if you prove an closed existential statement, then it's slashed. And if it's slashed, if an existential statement is slashed, that just means that there is some instance that is provable. So that is slashed, and hence is provable because by the first lemma. Okay. But then we get a lot more out of it than just that. We also get a bunch. First of all, we get a complete characterization of when that happens. So this is this thing that happens in proposition 513. If C is closed, and we have this existential definability property for consequences of C, then then C slashes itself. Okay. By induction on things that are derived from C, but that also includes C itself. Okay. So self-slashing is closed under equivalence. And then comes this important class of the Rassi-over-Harrop formulas. So this trick of trying to characterize the best set of, or at least, so now we know that you can get the explicit definability and the disjunction property for any consequences of self-slashing things. But now you want a better characterization of those. You want something that you can check syntactically, whereas self-slashing is more, you have to check provability and so on. So you want a purely syntactical notion of that it's sufficient for self-slashing. And that's where these Rassi-over-Harrop formulas come in. And I guess Rassi-over first studied this in the purely logical case, and then Harrop did the arithmetic. That's why they're both named here. So this is a class of formulas that don't have any existential quantifier or disjunction as a strictly positive part. So you all understand what that means? So they're never, a strictly positive part is something that's never on the left side of an implication. Okay, so the proposition is if C is Rassi-over-Harrop, then it slashes itself. And then as a direct corollary of that, if Heiting arithmetic proves for C a Rassi-over-Harrop formula that it implies a closed existential, then it implies an empirical instance. And if it implies a disjunction, then you can prove that it implies one of the disjuncts. And it's also clear that you have to have some condition, right? Because you could just take exists x ax implies exists x ax for some a of x, where that is closed, and then you wouldn't be able to extract an instant because you have to. So it's clear that you need some syntactical restriction. But this is a very nice class for which you get this. Yeah, the proof is not hard. And then the corollary is that any negation at all is Rassi-over-Harrop. So that's good to know. All right, that was just going through it, and that one was very quick. So I guess we can talk about anything you would like now. We can try to finish up soon. So any questions?
Can you state again why we introduced the slash notation at all?
In order to prove, in order to characterize when you have the disjunction property and the explicit definability of numbers property. Right? We want to characterize.
No, it says that. But doesn't do why.
Well, what is a characteristic thing about formal constructive systems? Well, one of them is you can extract algorithms, for instance, right, in these things. And even more basically is you can find witnesses for existential statements, right? So, well, I guess it's all well and good to know that if Heiting arithmetic proves x is x, ax, then you can extract a number. But maybe you're also reasoning under some assumptions, right? Let's say you're doing something, you want to assume something more than just arithmetic. You have, then I think it's good to know that if you have something that's purely negative, or say just a negation, you have not be. Then you can still extract a witness, even though you're dependent on some other assumption. And what we want just maybe not just maybe you want a general class of formula C, for which you can get that this implies HA proves C implies AN for some
bit more like fine-grained extraction
Yeah, it's,
on positive, or strictly positive occurrences of these existentials and the disjunctions.
yeah, so you want to be able to get more, you want to take advantage of the fact that, so one way of thinking about this is this, I guess, the Chrysalis program, I guess. What more do you know if you prove something constructively than if you've proven it classically, right? Or in general, if you've proven something in some formal system as opposed to just proved it informally, what more do you know? And one thing we know about these formal intuitionistic logic systems is you have these explicit definability properties. And we want to get, we're not satisfied just with having, for this case, when we can also get this, why stop there? I mean, we have this further thing, right?
Okay.
Yeah.
I thought it was to get the first case.
No, you can get that
I was like,
the simpler methods. With
it
simpler methods.
seems like it.
Yeah.
Okay, I got it.
I guess just to fill in the time, we'll get back to normalization in type theory, and I guess for logic later, and going from here to HA improves AN sum in something you could also get from normalization, right? Because if you normalize this, then this has to end in an introduction rule, so it has to end in and in this, and then you could extract it like that. So it's also interesting to know that there is a technique by which you could extract this witnessing even under something. Say you're formalizing something in a proof of system, and you need to rely on some other problem that's very hard to formalize. But suppose you're lucky enough that this very hard to formalize proposition lies in the Rasti-over-Hare class. Then you don't need to formalize it. You just formalize this implication. You can still extract the witness. So that would be good to know, right?
That's pretty cool.
Yeah.
Oh. That seems like a pretty large class.
Mm-hmm.
Thank you, that helped a lot.
Okay. All right, any other things? Oh yeah, well, now we're on the topic of the slash. We'll do, I hope we'll get to do topos semantics, and then you'll see that this generalizes to the topos semantics case as the notion of a fried cover. So you don't have to know what it is, but it's something that you can take these techniques that we're talking about classically in the high arithmetic case, and we'll see them turn up again and again in type theory or topos theory later. So it's something I want to add now. That one reason why you might want to know how this slash construction works, so you can be ready for those further applications. Okay. Any other questions from the viewers? I'm sorry I couldn't set up a Freenode account during the lecture, but next time maybe we'll have an IRC channel open. But I'm sorry I can't make it this time. Give you a couple of minutes and then we'll stop the broadcast. That's it for today. And I told you I updated the website with the program for the next week. I'll also send you an announcement email. Next week, we'll do the Bauer theorem and the Fan theorem and the applications thereof in Brouwer's intuitionistic analysis. So. Okay, so Todd has a question. I'm trying to understand exactly what the question is. It'd be nice to know why the form of the definition of slash is sufficient with its minimum modification. Well, Todd, have a look at the proof, but also and compare it to the proof using the Kleene slash, which is where you modify the condition for disjunction instead. So I guess that's what I would say. But and also, one thing you could try is try to prove the disjunction property using just the the 45 realizability version of the slash, where you don't have any extra truth conditions or probability conditions. And that's all I'm going to say about that right now. And next question is, the generalization of the slash relation is the Freyd cover, F-R-E-Y-D, Freyd cover. Yes, it has to do with tokuses. Okay, I'm going to stop the broadcast. See you next week.